This video is about geometric series. So when we're looking at a geometric series is made up of a list of numbers that we're adding together. So let's say I start with 2, and let's multiply each term by 3. So this is our first term. The next term would be the second term. And if I do 2 times 3, I'd get 6. That's my second term. Next one would be my third term. Multiply by 3 again, I get 18. Next one would be my fourth term. Multiply by 3 again. It's 54. Let's make that our series right now. Right now we're going to be working with finite series, which means they'll end. So this is a sequence because we haven't added them together yet. If we add them together, that is when it becomes a series. So a series is when we're adding together. We call this geometric because every time we're multiplying by a number. It doesn't have to be 3 every time, it can be any number. So 2 plus 6 plus 18 plus 54 will equal 80. And this is called the sum of the series. Now, if there's just 4 terms, that's pretty easy to find the sum. If there's a lot of terms, that makes it a lot harder to find the sum. So we came up with a formula. I guess I should say mathematicians came up with a formula to find the sum for any number of terms we want to work with. And this formula makes it so we don't have to add up 100 things. We could just use the formula to find the sum. So n stands for the term you're working with. So, maybe they want you to find the first 20 terms added together. That would be n equal to 20. R is the common ratio. It's what you're multiplying by every time. And A sub 1 is saying the first term. So for example, let's say we have the sequence negative 45, 135, negative 405, 1215, and negative 3645. And we want to find the sum for this. Well, first we have to identify a couple of things. I said A sub 1 was the first term. So looking at our list, the one that came first was negative 45. That would be A sub 1. The common ratio, we have to figure out, well, what would I multiply negative 45 by to get 135? If I'm not sure, that's kind of a bigger setup. What we can do is we can do 135 divided by negative 45, and that would give us our common ratio. So if you take the second term divided by the first term, or you could do the third term divided by the second term, any 2 terms that are right in a row, you can find the common ratio. So this is R for the common ratio. And then there are 1, 2, 3, 4, 5 terms. So our sum for those 5 terms would be the first term times 1 minus the common ratio, negative 3, to the fifth, because that's how many terms we're working with, all over 1 minus negative 3, 1 minus that common ratio again. So we need to simplify this. Negative 45 times 1 minus Negative 3 to the 5th is 243. I should say minus 243, because negative 3 to the 5th is negative 243. When you do have minus minus, that's really plus, so we're saying 1 plus 3 on the bottom, and 1 plus 243 on the top. So negative 45 times 244 over 4. Plugging that into a calculator. Gives me negative 2,745. That would be the sum of that series. Now they could take another one where they don't write out every term. Let's say we want to find the sum for the first 8 terms. And 120 plus 60 plus 30 plus 15, and then dot 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 means keep going in that same pattern. A sub 8 would be that 8th term. So we could find all 8 terms and add them together. That is an option. But we can also use this formula. The sum of all 8 terms is the first term, it's our 120, times 1 minus r. We still have to find that common ratio. If I do the second term divided by the first term, we get 0.5 to the 8th, because we're working with those first 8 terms, all over 1 minus 0.5. Again, we have to simplify. 0.5 to the 8th is 0.00390625. If you wanted to, you could also leave it as a fraction. 1 minus 0.5 is 0.5. 120 times 1 minus the 0.00390625. That will give us 0.99609,375 over 0.5. And putting that into my calculator, timesing by 120 and dividing by 0.5 gives me 239.0625. Now they'll more likely round at an earlier place, like 239.1. But you shouldn't round until the very, very end. You don't want to round in the middle, or else it will make your answer a little bit further off. So that is finite series. If we have an infinite series, that means we're going to have something that adds together forever. If I just put dot 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 on the end without having another term, that means this is going to add forever. And we have 2 possibilities. We have the possibility where maybe it keeps adding together forever and it just keeps getting bigger and bigger and bigger. It never ends. So 2 plus 3 plus 4 plus 5 plus 6, these numbers are only going to get bigger and bigger and bigger. It's just going to go to infinity. There's going to be no limit on it. We do have a possibility, and the best way to represent this is by using the box. We know this box has a certain area. If it's a 1 by 1, we know that that area is 1, and let's give it units just so we can talk about it, 1 centimeter squared. But I could also write this as half the box plus, so I'm going to keep cutting it into halves. Now I have a fourth of the box plus an eighth of the box plus 1/16 of the box. And I can keep cutting this into halves forever. I can keep going. Obviously, since I'm on a computer screen and even you can't draw it forever, but technically I could keep cutting those into pieces forever. So I'd really be adding 1/2 plus 1/4 plus 1/8 plus 1/16 plus whatever else I got, and I could keep adding those together, but we know all of these together would still equal that same area. We already know the box has an area of 1 centimeters cubed, or squared. All of these added together would actually converge to 1. They would reach a limit where it can't get any bigger than this. So the way we know if an infinite series converges or diverges all depends on that common ratio. So again, we represent the common ratio as R. That's what we're multiplying by every time. It can also be written into a formula. So you may not have seen this symbol before. This is called sigma, and it means take what you have and keep plugging in numbers to keep adding. So I think I need to do something a little more concrete to show exactly what this sigma symbol would mean. First though, a sub 1 is still our first term, r is that common ratio, n is the nth term, whatever term we happen to be working on at the time. So we can write it like this. And let's do something a little more concrete so we can show exactly what this new notation means. Let's say this is our sum. The sum from 1 to infinity is 2 times 3 to the n minus 1. So what we're going to do is we're going to have to plug in every value that n could possibly be. Well, n was the term that we were working with, so we have a first term, a second term, a third term, a fourth term, forever. So first I'd start by plugging in 1 for the first term. 2 times 3 to the 1 minus 1 is 2 times 3 to the 0, or 2 times 1, which is 2. So for my first term, I got a number out of 2. Well, doing it again now, I'm going to move up to the second term. The second term, we plug in 2 for n. If I plug in 2, you get 2 times 3 to the 2 minus 1. It is 2 times 3 to the first, or just 2 times 3, which is 6. So that's what I got when I plugged in 2 for my second term. Now I plug in 3, because we're looking at the third term. 3 minus 1 is 2. 3 squared is 9. 2 times 9 is 18. Now I could keep doing this and plug in 4 for the fourth term, plug in 5 for the fifth term. But I'm just going to put plus dot 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 dot. So this is another one where this would not converge. 2 plus 6 plus 18, these numbers just keep getting bigger. For something to converge, you've got to be adding smaller and smaller numbers every time. If you keep adding bigger and bigger numbers every time, you're just going to be getting closer and closer to infinity. But mathematically, what if I just want to know from here, would this converge or would this diverge? Would this go to something we could actually add together, or would it just go to infinity? So the way we determine that is by that common ratio. If that common ratio is greater than or equal to 1, the series will diverge. If that common ratio is less than 1, the series will converge. So for this particular problem, the common ratio was 3. That means the series will diverge. Now, I did put absolute value bars around this because it doesn't matter if the common ratio is positive or negative. Even if that common ratio had been negative 3, the absolute value of negative 3 comes out to be positive 3, which I didn't need the absolute value bars for anymore once I make it positive. Sorry about that. Comes out positive 3, which is still bigger than 1. So basically, those absolute value bars are saying ignore the sign. If the common ratio is bigger than 1 when you ignore the sign, we diverge. If the common ratio is smaller than 1 when we ignore the sign, then we converge. So let's look at another example. So we could write it in that sigma notation format, or they could just give you a list of numbers. So we're not sure if this would converge or if it would diverge. So we have to find that common ratio. To find the common ratio, we take the first term and divide by, we take the second term and divide by the first term, which would give us negative 2. So ignoring the sign, we say, okay, 2, that's bigger than 1. This will diverge. Let's say this was our list. Now if I take the second divided by the first, that gives me 0.25. Ignoring the sign, this is smaller than 1, which means this converges. When it converges, we can find the sum. We can find the exact sum using a different formula from when we had a finite sequence. If this is going forever, we just use the formula a sub 1 over 1 minus r. So the first term divided by 1 minus the common ratio. So for this problem, the first term is 100. Common ratio we found was 0.25, which means we have 100 divided by 0.75. And when we divide that, we get 133.3 repeating. So just one last example. This time we'll work on it in sigma notation. So looking at the common ratio first, that's what is inside the parentheses. We can determine 4/5. If we plug that into a calculator, we get 0.8. That is less than 1, so we converge. And we can find the sum from this. The sum is the first term. Remember, on this notation, the first term is the number in front of the parentheses. So 2 over 1 minus that common ratio of 4/5, or you could have written it as the decimal 0.8. So 2 divided by 0.2 would give us 10. So adding up these terms forever actually comes out as the number 10. So that ends our discussion on geometric series.